All right, so today we're doing 11.4, multiplying and dividing rational expressions. If you read to multiply rational expressions, you multiply the numerators and multiply the denominators, and then you simplify. So see, we have this 2c squared f over 5ab squared times a squared b over 3cf. And so when we multiply our numerator, we end up with 2, and I'm gonna just put it in alphabetical order. A squared B C squared F. So I basically combine those variables and put them in alphabetical order. At the bottom, we have 5 times 3 is 15. Then we have A B squared C F. And so we multiplied the numerator and denominator, and now we're gonna simplify. Can 2 over 15 simplify? No, it's already in simplest form. So now with our variables, we're going to do our multiplying exponent rules, which says if on and dividing. So here we're dividing. So when we're dividing, if they have the same base, we're going to subtract the exponents. So on our A's, we're doing A is 2 minus 1. Our B's, if we subtract from top to bottom, is 1 minus 2. Our C's, C minus 1. And then our F's basically cancel because it's F. 1 minus 1 is 0. Anything to 0 is 1. So those basically cancel. And so when we write our final answer, this becomes A to the 1 power, B to the negative 1, C to the 1 power, and I'm going to combine it with my 2/5. So I end up with 2/15, A, B, negative 1, C. Now this isn't simplified to its lowest terms, because, hold on, I'm just trying to process something real quick. I'm trying to double check that I have the right answer. Okay, yeah. This is simplified to its lowest terms because remember a negative exponent rule, if we have a negative exponent, in order to get rid of that exponent, we must move it to the opposite side of the fraction. So 2ac is going to stay in our numerator, and the b is going to move to the denominator down there with the 15, and so this becomes 15b. And so that is our final answer. Everybody got it? All right, let's practice another example. So we have 6ab over a squared b squared times a squared over b squared. So I'm going to multiply my numerator, and so I end up with 6. Same base on multiplications. We add the exponents. Remember, there's an invisible one here and an invisible one there. So we add those exponents, and so we end up with a cubed b. And on the bottom, we multiply a squared just by itself. Same base on the b's. We're going to add those exponents, and so that's going to become b to the 4th power. All right. Then we divide, and that gives us 6a. I'll do the math just so you don't get confused. On the A's, we're doing 3 minus 2. On the B's, subtracting from top to bottom, we have 1 minus 4. That ends up becoming 6ab to the negative 3rd power. We have a negative exponent. So our negative exponent rule tells us we have to move it to the denominator. This is all over an invisible 1, so it just goes down there. So this becomes 6a, and the b cubed goes to the bottom so that it becomes a positive 3, and that becomes b to the 3rd power. And so our final answer, oh, I'm sorry, I didn't know you didn't see it. We have 6a all over b to the 3rd power. So pause that, absorb it, and I'm gonna move on. All right, so here we're multiplying m minus 5 over 8 times 16 over m minus 5. So when I multiply my numerator, I'm gonna leave that 16 outside, and so I have 16 times m minus 5 in the top. Then on the bottom, I have 8 times m minus 5. I'm not gonna distribute that 16 or that 8 because then I'm gonna end up having to pull it back out because it's gonna be the GCF. So I'm just leaving it like this because if you notice, our m minus 5s end up canceling. And so that leaves us with 16 divided by 8, which ultimately the answer is 2. Got it? All right. And finally, on the multiplication side, we have x squared minus 16 divided by 2x plus 8 times x plus 4 over x squared plus 8x plus 16. And so we see here, unlike the top, at the top we had monomials. We're just multiplying monomials, getting polynomials and all that good stuff. Down here, it was already factored for us. We just kept our GCF outside. Down here, it's not factored for us, so we have a quadratic function where we're going to have to factor. But the good thing about it is if you look at it, this one is a difference of square. So all we're doing is just taking the square root of that one. And so this one, if we draw two factors, square root of x squared is x and x. Square root of 16 is 4 and 4. And then remember, in order for our middle term to cancel out, we have to have opposite signs, which is a positive and a negative. This denominator is already, it's not factored either, but we don't see a square. But if you look, it has a GCF. And hopefully you notice the GCF was a 2, so I'm going to factor out a 2 out of this 2x plus 8, which means I'm dividing both of them by 2. And so that leaves us with x plus 4. All right, then I'm going to multiply it by this side. X plus 4 is the numerator. And then if you look, I have a denominator that I need to factor. This is another one that's pretty easy. If you look at that, it is a perfect square. I could take the square root of the first term, and I get x and x. Square root of the last term, I get 16. Oh, not 16, I'm sorry, I'm tripping. 4 and 4, both signs are gonna be a positive. If you wanna double check, just cause you might think you're not right, if we do our inner term, we get 4 times x is 4x. Our outer term, 4 times x is 4x. 4x and 4x gives us our middle term, which is 8, so yes, that is a correct factor. If you didn't know this was a perfect square, then you would have just solved it like normal, where you did your t-chart of a times c to see which one gives you bx. Which factors is 16 can get you to 8x, and hopefully you pick those two, which are 8x, and so that's how we got positive 4 and positive 4 in both ways. So now that we've simplified this quadratic, we can go through and do some canceling. So here, this x plus 4 can cancel this x plus 4. This x plus 4 can cancel that x plus 4. And then all we're left with in our numerator is x minus 4. That's all that's left at the top when we multiply. And on the bottom, we're left with a 2, and we're left with an x plus 4. And so that's as simple as it can get. So we're going to go ahead and multiply. And our answer is going to be x minus 4 over 2x plus 8. And that is the final answer for that paper's moving problem. Got it?